Good evening, ladies and gentlemen. This is Zack Stockbridge. Welcome to the Opposition of Mars live stream. I'm sitting here in North Carolina, and we are under beautifully dark skies tonight. So here we go. Sorry, I've got emails coming in already. Okay, so the goal is to start with Mars this evening. Unfortunately, I'm at a brand new location and Mars is up and behind a tree. So we're going to change plans just a little bit. Mars will be out from behind the tree, hopefully in just the next couple of minutes here. So we're going to head on over and take a look at some of the big planets, which are a lot easier to catch. So without further ado, let's head on over to Jupiter. So this is the live stream through the telescope. Don't worry that it doesn't look like anything. We are getting ready to change that momentarily. Hold on, you caught me just in the last stages of some alignment. Telescope alignment took a little bit longer than expected. So let's get Jupiter back into the view here, and then let's get him focused, because right now you're probably looking at it and thinking, well, that's pretty boring. But don't worry, we are going to change that in just a moment. All right. What have we got here tonight, Sir Jupiter? Now, just so you guys are fully understanding everything that's on the screen here, this is the software that we use, many amateur astrophotographers use, for doing image capture. Because what we do is when we look at the planets, or at anything, oh, there we're getting a little bit, we typically don't take pictures, individual photos. What we do is instead, we'll take video. Because you see how Jupiter is shimmering in the view there? That is the result of just turbulence here in the Earth's atmosphere. And there's really no good way to stop that, obviously. But amateur astronomers are a clever bunch. And so what we do is we just find ways to try and get around that. Whoops, sorry. Learning my way around some new software here. So what we do is we're actually going to take video at an extremely high frame rate. We're basically going to go as fast as this camera will allow us to go. And what that does is that allows us to take advantage of what we call lucky seeing, which is basically we're going to take video and we're going to try and catch, we're going to try and catch just the stillest, most crisp images in the whole video, those brief, fleeting moments of really still atmosphere, and we're just going to use those individual frames to make our total image. Now let me go ahead and see if we can get Jupiter framed up a little bit better here. There we go. That's a little bit better. Now, the other thing that you might be wondering is why aren't we seeing this as a color image? Well, in astrophotography, especially when we're dealing with planets, we really don't want to use color, believe it or not. The reason being is that in your color camera, you ever wonder how a digital camera makes color? Well, what it does is it takes all of the pixels in the camera and it makes a grid out of them. Let's try and get this guy focused while I talk. Sorry, I can't chew gum and talk at the same time. So we have this grid of red, green, and blue pixels. And your camera takes a photo and it basically records the level of brightness in each of those, and it has patterns for putting them all together. And then that's how we create a color image. The trick is, when you do that, you end up sacrificing some resolution because it takes 4 pixels to boil everything down into one good piece of color. So what we do in astrophotography is we tend to prefer, when we can, taking monochrome images. So just black and white, but the black and white gives us an advantage because every last pixel in the camera goes into increasing your resolution, so you get more detail out of it and not just color. And what we're going to do is we're going to cheat a little bit here in a while. Right now this is just the black and white view, but what we're going to do is I'll eventually slip in a bunch of filters into the camera system here, and what that's going to do is that's going to allow us to take pictures in the red, the green, and the blue, each of those different filters. And then I'll go into Photoshop. I will put them all together a little bit the same way that a camera will do it, only cameras are obviously automatic. And then what the camera will do, or the color will do in Photoshop, is we can actually play with it and we can balance how much red, how much green, how much blue, and really bring out the details. And it's kind of neat looking at things through the filters, because when you do, they bring out different details and different aspects of whatever object you're looking at. And we'll see that on Mars, which I'm looking at, and it looks like it is just, oh, it's still skirting the treetops over there. So let's keep playing with the king of planets. So what we'll do, oh, come on you. Come on Jupiter, don't drift away on us. There we go. So we'll take all of those individual frames, we'll stack them together into a color image, and then we're away to the races. Now there's actually something kind of interesting happening on Jupiter here. We have a lot of turbulence tonight in the sky. The seeing just isn't all that great, unfortunately, but sunset was just a little while ago. Hopefully the atmosphere will continue to settle down, and the seeing, which is the way that we refer to just how much shimmer or how still the image is, hopefully the seeing will improve. But I'm going to turn up the brightness here a little bit on the camera. So right now I'm taking a 9.2 millisecond exposure in this video. Let's turn the brightness up. We're going to ruin the planet, but look what else appears. See those guys? 1, 2, 3. Those are moons of Jupiter. It's Callisto and Europa and probably Ganymede. I was looking just a couple minutes before the live stream began, and there was another moon, I think even closer than that one is to Jupiter. Yeah, let's bring it back down in here. So either Io was just getting ready to go behind or in front of Jupiter, or it's just now coming out from being behind. Actually, yeah, based on how close it is, I'll bet this is Io right here. But if I can go off screen here for you guys just a second, let's pull up my, whoa, shucks. Uh-oh. I bumped the telescope. Alright. That might be a problem, but hopefully we can solve it. here in a moment. Let me go ahead and we're going to try and figure out which of those moons we're looking at here. And I'm going to do that by opening up Sky Safari, which is my astronomy app of choice. Alright, so this is Sky Safari right now. Mars is off to the east, but Jupiter and Saturn are off here to the south. Here's Jupiter right here, and we're going to use Sky Safari to go ahead and zoom in. We're going to zoom in a lot. Yeah, let's get a little more real estate on the screen here. Hello, Jupiter. Okay. Now, the camera on the telescope is not rotated 100% correctly. That's why we're going to see a little bit of a mismatch between what was on the camera, and I'll rehunt and find that again in a second, and what we do have here for Jupiter. So we had one moon right up close. Let's see if that was Io. It was not. Ah, surprise, surprise. So that was Europa. And then we did have this guy off to the right. It was Ganymede. And there's Io. And if we moved the telescope around a little bit, way up here on the upper left, that's Callisto. That is also one of Jupiter's moons. These four are known as the Galilean moons because they were discovered by Galileo Galilei. All right. Let's put the phone away for a minute here, and let's see what we can do to try and re-find the King of Planets. Well, actually, you know what? Let's go ahead and let's do this. I'm going to give you guys a quick pause here. And what I want to do is I'm going to give you a brief little tour of the equipment that I recorded earlier today. And while you guys watch that, I'm going to go ahead and re-find our target here, because trying to find something in the telescope with the camera in and a Barlow in for extra high magnification is it's not an easy thing. So here you go. Sit tight for a couple of seconds here and take a look at a quick tour of the telescopes we're using. Right now, I do have two telescopes set up. One of them was in the last stages of aligning itself because it's computer controlled. We're looking through my telescope here, which you'll see in a moment, which is not computer controlled, although it does have a nice little old-fashioned tracking motor. So I'm trying to kind of get a lot of different programs to talk to each other here. All right, and I also have the comments up here on the live stream here. If you guys can't hear me for whatever reason, then please go ahead and shout out a quick comment in the live chat so that I know that I need to fiddle with the audio settings a little bit. They should be good. I tested them earlier, but you know how technology goes. All right, I'm going to go find Jupiter and also get us positioned for Saturn while you guys take a look at the equipment that we're using tonight. All right, I don't know exactly how good the audio is going to be on this, but we're going to give it a try. thought I'd take you on just a very quick tour of the telescopes for this evening. So this is my personal telescope. It's an Explore Scientific. It's a refractor, which means it's based on lenses and not mirrors. And it has a diameter of 127 millimeters. It's a very nice refractor. Sometimes smaller telescopes are better for lunar, solar, or planetary imaging, because even though they don't gather as much light, they are taking a smaller column of air, if you will, because their diameter is smaller, and therefore, you know, all of the turbulence, all of the waviness that you see when you look through binoculars or a telescope at any kind of object, that's from looking through the entire atmosphere. And the bigger the scope you look through, like that monster over there, which we'll talk about in just a moment, the bigger the telescope, the larger the diameter, the more turbulence you're looking at, and that all kind of gets focused down and concentrated in the eyepiece where you're looking, or in the camera if the camera is doing the work. So sometimes you can get a better view through a smaller telescope because even though you're collecting less light, you're collecting less turbulence. This is just a standard mount. It is not computerized, although it does have a little tracking motor, and I've done a polar alignment, so basically if I've done a good job in pointing it at the North Star, this should do a pretty good job of tracking things through the night. This is not my telescope, but I wish it was. This is a Celestron 11-inch diameter, and it's a Schmidt-Cassegrain style, which means that it's got a little bit of a lens here, but it is mostly based on mirrors. So there's a mirror on the back there that you see, and it bounces the light forward. There's a secondary mirror on the back side of this guy, which we can't see, obviously, and it sends the light back down the tube one more time and out the back into the eyepiece, where we've got a great view. I have a finder scope there to help make things a little bit easier. This telescope is not only motorized, but it's computerized, and I'll be using the hand control there to steer around and find a bunch of our targets tonight. I did a test run with this. This is the Southwestern Community College telescope. They're over in Sylva, North Carolina, where I teach a couple of courses. And this is a great telescope. It was basically, seemed new out of the package almost with the coronavirus this year. It just has not been able to get a whole lot of playtime. So these are the two telescopes that we will be using. There are a whole bunch of different styles of accessories and everything. I won't bore you with the details too much, other than to say that is our camera. It's a ZWO camera. They're a company based in China that does really some great work making different cameras for amateur astrophotography. That particular one's an ASI 174. All the details other than that you don't really need to know for the moment. So this is what we're going to use tonight, and really looking forward to getting a look at Mars. It will be just over those trees here in a couple of hours as the sun sets. Jupiter and Saturn are going to be off here. You can see the tower. That's literally the local radio station. Jupiter and Saturn will be just over here. And of course we've got the sun doing its thing or that way. And we're hoping to catch Mercury before it sets as well. Alright, that's a quick tour of the equipment. You guys have a good one. Okay, that's the quick tour of the equipment. And we are still hunting again for the planets. I think what we're going to do is we're going to go ahead and try and move on. And we're going to see if we can find Saturn. Actually, you know what? We're not going to do Saturn. Mars is just above the horizon over there. Looks like it's finally cleared the trees. So we're going to go ahead and head over there, take an early look at Mars, and then we'll come back and find Saturn later, because Mars is the star of the show tonight, and so that's where we're going to go. Sorry for the delays here, ladies and gents. As always, all of the technology problems have waited to happen, not just at the last minute, but at the worst possible time. So, just working on finding everything here. Alrighty. Well, we've got a double star here, but that's not what we're after. We're after the red planet. Come on, Aries, where are you? Alright, hold on just a moment, ladies and gents. I'm going to put the microphone down. Well, while I'm hunting for Mars, I'll continue to try and do this one-handed. Let's talk about what opposition is and why it's just kind of a big deal here that we're able to see Mars so well these days. What it basically comes down to is, as you know, the orbits of planets are not circular. They are elliptical. So slightly egg-shaped, if you will. And as a result, there are times when planets are closer and further, but a lot of it also just comes down to where the planet is in its orbit. Mars orbits much, much more slowly around the sun than the Earth does. It takes about 1.9 years to make it around, whereas we kind of speed around in 365 days. And so there are literally times when we are on the opposite side of the sun from Mars. And as a result, the distance is really great, and therefore Mars appears to be much, much smaller in the sky. Well, every 26 months, and one of the reasons that astronomers are really excited about this particular opposition of Mars is that the last time Mars came to opposition was in late July, early August of 2018. Well, right as the planet was getting nice and close and getting big, we had an unfortunate event, and that was that there was a dust storm on Mars. Mars has very little atmosphere. The density of the air is extremely low compared to that of Earth. And the result is that dust remains in the atmosphere for a much longer period of time. Aha! All right, we've got Mars. Let's see if we can fine-tune it. And again, Mars is very low in the sky right now, so we're getting lots and lots of turbulence. Back to the story. So astronomers were, especially amateurs, were very excited to get out and see Mars, and just as it was reaching its best a couple weeks beforehand, that's when the dust storm began. And dust storms can cover the entire disk of the planet. They can basically just wipe everything out, which is no fun. And just sometimes that happens, and this was one of those times. But one whole half of Mars was just completely obscured, nothing there to see at all, and the other half was not doing a whole lot better. You could see a little bit, but that was it. And it basically came down to, you could see the ice caps, but nothing else. So we're very happy that this time there is lots going on the surface of Mars. A lot of great stuff is visible, and we will see that here in a couple moments. I just need to get the camera settings to the right spot. You'll see me fiddling with two different settings here as we go. We have the exposure, which is how long the image collects light before it processes it into an image. And then we have the gain, and gain is basically like the sensitivity of the camera. You can change the settings and the sensitivity. Usually the goal is to have the lowest gain possible to match your exposure setting. And come on, Mars. Ooh, the atmosphere is just really, really lousy off there towards the east. Right there is about the best focus I can get on this, which is honestly pretty terrible compared to a couple nights ago. Let me just briefly pull up a quick photo to share with you guys for what Mars looked like when I pulled out the telescope on it last week. Now, this is after a bit of processing, but that's what Mars looked like less than a week ago. I think I was out here, let's see, it's Tuesday night. I think I was out here Thursday night, and that's when I got this image. Now, all is not lost. As I said, Mars is still very low in the sky, so hopefully we'll be able to get some good views of it here in a little bit. But at the moment, we just have a lot of turbulence. And you know what, that's just kind of life. Amateur astronomy, amateur astrophotography I should say, really is a game of patience. No matter what happens, you got to deal with the weather. And it takes time, and you wait for the perfect window to appear so you can get the best image possible, and then you make hay while you're able to. All right. All right, we're going to do a couple things here. So I'm going to switch over and I'm going to try and get the filters in, and we're going to take a look at Mars through the filters, and you'll be able to see how that will impact our view. And then I'll also attempt to go ahead and get some image data while you guys are watching here, and I will process those later tonight because, hey, who needs sleep? I'll process the data and turn them into regular still photos and try and get those into color and share those with everybody, either in a summary video here on the YouTube channel in the next couple of days here at the AstroZack YouTube channel, or I use the same handle, AstroZack, over on Instagram, and you can get the posts over there. Why AstroZack? Well, honestly, because I couldn't come up with anything more clever when I was signing up for my account all those years ago. So, all right, I'm going to keep working on Mars here. In the meantime, one of the goals for this session was to do a solar system sweep, and that's a challenge that I just kind of invented for myself a number of years ago. My wife was not home. She was out visiting a friend for a number of days, and the way that the planets all came together, I realized that, hey, I was just having a good night at the telescope, and I realized I can probably see all of them. And I double checked everything in the planetarium, and indeed, that's what happened. All the planets were visible, and I just kept going through them, and I decided, hey, I'll bet I could do a sweep. I'll bet I could get all of them. How about I get all of them and an asteroid? How about an asteroid and a comet? And let's try and find a dwarf planet at the same time. So it was a very long night, but I went out and I've accomplished the goal. I saw all of the planets in the solar system. I did get a dwarf planet. It was not Pluto. I did get the moon. I did get the sun because I put the solar filter on the telescope. And it was an interesting challenge, one that I've never attempted again because I value my sleep, but we actually almost had a shot at doing it tonight. Almost. So what I'm going to do is, here is a video of me with the H-alpha telescope, which is a dedicated solar telescope, and I was out this evening taking a look at the sun, and there are a couple of things that are actually up there. And again, I'm going to try and process some of this stuff and share it for you guys in still image form on Instagram. So let me switch you guys over, and you're going to take a look at the sun through an H-alpha telescope while I switch out filters and try and get a little bit better view of the red planet for us. With that being said, here we go. Here we are, 5:30 p.m. out in Cherokee County, North Carolina. I'm sitting in the parking lot under a blanket to cut down the glare on my screen because, as you can see, we're looking at the sun. This is a live view of the sun through my H-alpha solar telescope. So for those of you who aren't familiar, the sun gives off many different wavelengths, but it's made mostly of hydrogen. And hydrogen alpha is essentially the name of the one wavelength, the color of light, that the sun will give off the most of. And therefore we get the most detail when we use a filter or a dedicated telescope that only looks at that one color. Now you can see I'm getting a lot of turbulence here. The sun is starting to kind of get low in the sky, and so we're looking through a lot of atmosphere and just getting a lot of waviness as a result. But we're looking at the surface here, and it's fairly quiet at the moment. However, the nice thing is we can cheat a little bit. We can scroll around a little bit. Here, let's move around and see if anywhere else on the sun's surface has any other activity worth looking at. Well, it's fairly quiet. We're looking at a lot of plasma right now. The sun is all a glowing disk of plasma. But the exciting parts, when we're not near the bottom of the sunspot cycle, which is unfortunately still the case, the exciting parts often happen on the limb of the sun, which means out here along the edge. Now, the human eye is a marvelous creation. It can process dynamic range like nobody's business. And dynamic range is basically a fancy way of saying that our eye can handle really bright and really dim and put that all into a view all at the same time. Cameras, however, don't really have that ability. So here we've got a pretty good view of the sun's surface, but all of the stuff that's going to be happening out here on the limb is much, much fainter than that. And the camera just can't do the bright disk of the sun and this faint stuff at the same time. Now, it can do it at different times. So here's what we're going to do. We're going to take a quick picture. We're going to record a couple hundred frames of video here, and I'll compile those into a picture a little bit later. Let's see, we're getting up around 300 frames. Well, let's get up to 500 and then we'll call that good. Yeah, you can see there's a lot of shimmer in the sun right now. The seeing conditions, I'm in a parking lot, so the pavement is not that hot, but it's enough to add to the shimmer that we're seeing. If you hear any humming, by the way, that's some guys that are just out here flying their drones. And I'm hoping they don't crash into all of the expensive telescope equipment sitting 2 feet on either side of them. Alright, we've got a lot on there, so let's go ahead and we're going to bump it over and let's see what happens when we change the camera settings. And yeah, we're going to lose everything on the disk of the sun over here, but if we increase things enough, we can begin to see some prominences along the limb of the sun out here. Now, a prominence is a place where all of the plasma, or a bunch of the plasma on the sun's surface is simply trapped in magnetic field lines, which get incredibly tangled on the sun's surface. And basically, when they get trapped, they just have to follow the magnetic field. And they can arch up, or they can go up in pillars. They can have a number of different shapes, which can get pretty wild. Alright, increasing the settings a little bit more, and not really doing us any good there. Let's bring it back down a touch. I also haven't played with the focus on the telescope very much. Let's see what happens if I can get just a little bit better. Oh, wrong way. Yeah, there's a lot of shimmer there. We're just not in very good conditions. Really kind of around midday in this part of the country is some of the best. But, alright, let's take a quick picture there. Let's do a 10-second video capture. And then we're going to scroll around a little bit and see if there are any other prominences. This is the main action here, but you can see there's a tiny little guy right there. Alright, let's move around and see what we can see. Now we got helicopters going into the hospital. Alright, not a whole lot there, but if we move up, go up telescope, can see a few other little prominences there along the bottom. Let's see what's on the other end of the sun's disk. Again, we're near solar minimum, and so there's just very little activity on the sun these days. We just started a new solar cycle here in early 2020. Some people argue that it was late last year that we officially began, but kind of splitting hairs. Oh, that's a nice little prominence. So you have an actual arch. Goes all the way up and comes all the way back down. Let's get a couple quick frames of that. So we're at solar minimum now. It's approximately 11 years on the sunspot cycle, and there's a bit of variation in there, so it can be a little bit longer, it can be a little bit shorter. But basically, in 2024 or 25, we will see a lot more solar activity as we get closer to those dates. Let's bring it back down to see the sun's surface. Ooh, hey, there's a little something. Let's reframe there a little bit. Ooh, there are a couple somethings. And a bird flying through. Here we have a filament. So this is basically a cloud of gas that's detached from the sun's surface and it's puffed out a little ways. And the result is quite simply that it cools down, and that's why we see it as a dark spot. Here, this light stuff, this is an active region. That's a place where we could potentially have a sunspot. But there's a lot of magnetic activity there. Get this going while I chat. There's a lot of activity there, and you can even see a little bit of texture. You can see things swooping in and out. This is a place where a sunspot might develop. Sunspots really aren't visible in H-alpha, but they are very visible in white light. However, it's very possible to have an active region like this that does not produce a sunspot. I think I've about chatted your ear off enough there. Let me reframe. I'm going to take a couple more photos here and try and have them to share for you guys a little bit later. But in the meantime, this is the live view of the sun through a Lunt 60mm H-alpha telescope. It's a great instrument. I've been very happy with it. And if you guys want to see some solar images that I've taken with this telescope or my larger solar telescope that I also have from Lunt, check out my Instagram feed at AstroZack, where I've got a lot of different photos of the sun posted on. Alright, I hope you enjoyed looking at the sun. I've got Mars in the eyepiece, just need to put the camera back in there and then we'll be all set with the filters. So give me just one moment. Alright, here we go. I just plunked Mars in there with the camera. So now we begin the process that you saw before. We're just going to keep working on finding the right focus and then the right camera settings to make this view really good. Well, something happened. What's going on? Alright. I think my tracking motor is having a difficult time here. Every time I get it in the eyepiece, the camera protests. Well, there it is off the top. What's the technical term for this? An iterative process? Oh man, this poor tracking motor is just dying. In view again through the camera with the filters. Let's go ahead and fine tune this and see what we can accomplish. Step one is always to get the best focus you can. The smaller the disc appears, the closer you are to the focus. And we're way overexposed. But that's okay, one step at a time. Let's take the gain down because we're getting a lot of noise from that. Let's see if we can make this just a little bit larger on the screen. There we go. Alright, now this is still just a black and white image, so I can get a good focus, or get pretty close. Some people have autofocusers, or electronic focusers. So basically, instead of having to have their fingers on the dial for the camera, or for the telescope to constantly adjust the focus, like what I'm struggling with here, because that introduces a lot of vibration to the view. What they'll do is they'll have an electronic focuser, which they simply touch a button on their computer or a hand controller, and it will focus the camera just a little bit at a time, and it reduces the vibrations by a very significant amount. Wow, we are just very turbulent atmosphere tonight. even with the poor atmosphere, you can still see some things on the surface here. Let's play with our brightness settings and see if that helps us a little bit. Going brighter doesn't help. Going dimmer, we're basically right where we want to be. We can see some brown surface markings there. A little bit earlier, I saw one of the poles. We've got an air current moving through, as you can see. Our seeing has decreased even more. Well, we're going to take a risk here. All right, see, we're moving way out of focus. We're going to take a risk here. So this is still the black and white view, monochrome. What we're going to do is I'm going to use the filter wheel here, and I'm going to switch over. We're going to start putting some filters in. We've got red, green, and blue. Now, FYI, I'm putting filters in here, but remember that the camera itself is still just a monochrome camera. It's going to stay monochrome on the screen, but only the red light. Let's go ahead and switch over to the red filter. Position number 1 on the dial. Only red light is being allowed through here. That cuts down the brightness a little bit, so we'll adjust things a touch. The key thing that's important about the red light is simply that I know that it's red light, so that when we go to Photoshop or some other image processing software later on, that can get programmed incorrectly, and the program will treat this data file as red. And then we'll repeat the process for green and the process for blue, and then all of those can get combined into a standard color image. Wow, I think that's about as good as we're going to get at the moment. Let's try and wait it out for a second. And while we do, I'm going to bring Sky Safari back up, and let's see if we can identify any kind of surface features on the disk of the planet there. I'm betting we can, but we're obviously going to be a bit limited. Okay, Sky Safari. Hold on, let me get there. All right, so we were looking at Jupiter earlier, but we need to, whoops, what are you doing? We need to get over to Mars. So let's do a quick little search. We're going to go the fast way. Mars. And we want to center Mars. Zoop. Boom. And let's zoom in a little bit further. Oh, actually, before I do, see those two objects off to the left of Mars on the Sky Safari screen? Those are some of Mars's moons. So we have Phobos and Deimos. And these are very, very wimpy little moons. Unfortunately, there's no good way. It takes some actually kind of advanced techniques to try and spot the moons in the eyepiece or in the photograph, because it looks really good here on the screen, but when you take a look at it in the telescope, again we come back to that issue of dynamic range that I discussed in looking at the sun. The human eye has as good as it is, still has a kind of limited ability to process really bright and really dim at the same time. And basically what happens is Mars is just too bright. It has too much glare. You can see, whoops. You can see that these moons are not very far away from the planet itself. So Phobos here, which means fear, by the way. Phobos is only about one, if you take a look at the diameter of Mars here, it's maybe one Mars diameter in the image. And Deimos is a bit further, but that's just very, very close to the planet. So both of those, now again, we don't necessarily have the camera rotated correctly here to match what's on the screen, but one of them would be, somewhere around this distance, and the other probably getting a little towards the edge of the screen. There are some advanced techniques that you can use. I read about them in Sky and Telescope, and I tried one of them the other night. I tried making my own occulting bar, which is basically just you take a very thin sliver of aluminum foil and you put it in your eyepiece. There's a certain way that you can go about taping it in there. And when you do, the goal is to simply block out the bright object, the bright disk of Mars. And that way, with the glare of the planet gone, you're able to see the moon itself a little bit again. There's some other tricks as well involving some filters and basically cutting up a filter. But I was not able to get that ready for tonight. Let's just go ahead and see. We're going to intentionally overexpose the planet by a good bit here and see if perhaps those faint moons pop up just a little bit. Okay, no, those are not them. Those are just hot pixels on the camera. That's just noise in the system. And it's not too happy with this idea. Let's give it another try. Let's turn up the gain as well. Let's just push this camera to its limits. All right. Chances are the planet is, or the moons are just extremely trapped in the glare, and there are a bunch of light pixels in here, but you can see that they're staying still on the grid, which means that those are not something that the camera is seeing. Those are just kind of artifacts in the camera itself. Yeah. All right. I will eventually succeed at that, and when I do, I will share the images with you, ladies and gentlemen. Alright, let's see if we can get Mars a little bit better centered. We're going to go ahead and we're going to see if we can get a couple of images taken here. Again, conditions aren't very good tonight, but you never know what's possible with a little bit of image processing. Alright, so this is the red filter. Let me just take you on a quick tour of the filters before we start doing data. And perhaps one of these other filters will give us a better ability to focus. So with Mars being the red planet, we would expect to get the most detail and the most contrast and whatnot out of the red filter, and that looks like it's the case. This is the green filter, which we'll take over to Jupiter here in a little while. The green filter is actually very good for Jupiter and Saturn. Not so much for Mars here. And the blue, you're going to notice that the brightness is going to drop way down. Well, not quite as far as I expected. But notice that in all of those, we still did not get as much detail as was possible here in the red filter. Well, the image is stabilizing slightly, so tell you what, let's go back over here to Sky Safari again. Let's see what we can find in terms of identifying surface features. And actually, I'm gonna risk something here. I'm gonna try and rotate the camera a little bit so it's a little bit better match to what's going on our screen there. Aha, success. All right, wake up, phone. Not a bad comparison. All right. Let us see what is possible here. Oh, come on, phone. You're kidding me. There we go. Wow, it's really... turbulence is really bad tonight. The other night you could see the polar ice cap clear as a bell. And tonight, I mean, that might be it right there, but that's pretty tough. So we have this dark marking over here on the right. I think the rotation of the camera might match what's on the app right here. So the dark marking on the right here is Terra Sirenum. So Terra means land, Sirenum, land of sirens. Let's see what's going on in Terra Cimmeria. Not Sumeria, Cimmeria. Not too shabby. Not too shabby. Okay, we are going to go ahead and let's put Sky Safari away a little bit. We're going to try and get some image data here. And so, God willing and the creek don't rise, tomorrow on Instagram I'll have some images posted here for you, ladies and gents. And by the way, all the imaging that we're doing, all the viewing so far, this is through my telescope. We still haven't pulled out the big telescope. It was having some problems with alignment earlier, which was no fun. But the tracking motor, the computer seems to be working, and now that things are improving with Mars, we're going to switch over and put the camera view in that telescope and see what kind of difference it makes. So here again, we're looking at Mars through the refractor, which is 127 millimeters in diameter compared to 11 inches. And I'm trying to think what that is. I can't do that conversion in my head at the moment, but an 8-inch telescope is over 200 millimeters, so it's a good bit bigger. We're basically looking at a 5-inch versus an 11-inch, so we get a lot more data, a lot more light when viewing with the big telescope. So we'll just take a basic image here. You know what? I think I'm about as happy as I'm going to get with this particular focus. Well, no. I'm always trying to tweak it and make it just a little bit better. I probably shouldn't, but I'm going to. Alright, we're definitely moving out of focus there. Alright, let's take it way out and see if we can just gradually come back in. Alright, ladies and gents, that's as good as we're going to get. So what we're going to do is I'm going to take a sequence of images of Mars here. I'm going to try and get it relatively centered. You see that it gradually drifts just slightly to the left. So I'm going to take a series of images here. I'm going to go red, green, and then blue. And okay, down here you see that we're getting image data at 55 frames per second. We're actually going to try and speed that up by just looking at a smaller field of view. See, we've got a lot of black in the screen here that's just empty space. We can speed the camera up a little bit, in theory, if we just clip out a bunch of that extra. And what would it look like if we went even smaller? Okay, ladies and gents, here we go. This is Murder, She Wrote. So what we're going to do is we're going to take about 15, let's go, whoops, not minutes. We're going to go with 15 seconds of data on the red, and then I'm going to switch over to green, and then I'm going to switch over to blue. Yeah. All right. Go, go, go. So we are now recording a video of Mars. We're getting it in the red. And video is done. So we're going to swap over to the blue as quickly as we can. Or I'm sorry, to the green. G. Ooh, that looks terrible. But again, we're going to do what we can. We're going to collect the data, and then we're going to see what happens in the image processing overnight. It's okay if I shift things and adjust where the planet is on the screen between exposures. I just don't want to do it during. But the software is going to line up all of these individual frames later on. So, all right. Let us see Jupiter. The telescope says it found him. Let's see if it's telling the truth. It is not. Okay, sorry for the blank screen there. Jupiter is finally found. Well, he's found in the eyepiece. What is going on with the camera? Now, here on the black screen of death, Jupiter might actually be there. We might just need to change our settings so that we can see him. Okay, nope. Whoa. Well, there's somebody. Aha. All right, now, as the daughter of a good friend used to say, see Jupiter? Whoa, what's going on here? camera, the tracking motor, the hand control is not. There we go. Alright, so this is through the 11-inch telescope. We're obviously way too bright. The planet's overexposed, but you can see the moons again. So let's take this down a ways, and then we're still going to have to play with the focus. Ah, blast. Unfortunately, the big telescope is not going to give us any good views tonight. There is dew that is already built up on the lens, and as a result, the image quality out of this telescope is just in the toilet. Which is a super bummer. However, what we'll do, and oh, you guys don't know what I haven't shown you what a dew shield is yet. So when you got the tour earlier, you'll notice that the white telescope was a little bit longer, and it basically has a part of the cylinder extends out from the lens to keep moisture from building up on here we go. Keep moisture from building up on the glass. Unfortunately, the Celestron doesn't have one of those, or at least I don't have one with me. There are also electric straps that you can use that are dew heaters. And they will just gently heat the glass and keep it from getting condensation on it. I don't have either of those, and I wasn't able to fashion anything for any kind of improvised version. And that's why we're getting a lot of problems with dew on the big telescope and no problems with dew on my telescope. That is still a bummer though. Okay, what we're going to do is we're going to send this telescope over to Saturn real fast. And even though the view isn't going to be great, we should still be able to see the rings. And we'll swap back over to my telescope, which does not have dew building up on it, and see what we can find as far as Saturn and rings and some detail here in just a second as well. Alright, so Saturn is in the finder scope. And we're moving slowly, but we're going to get there. All right, we should be right on top of Saturn. There we are. Oh, it's faint, but there it is. And actually the faintness, we can help a little bit by changing the settings on the camera. So yeah, we've got a lot of dew on the screen now. Here, let's turn this up. You can see how it's just hazy all over the place. That's a result of the dew on the, almost said on the screen. The screen on the computer definitely has a lot of dew as well, but well, even with the obstructed view here, we do still have a nice little view. You can see the disk of the planet, you can see the rings, you can see the gap between the rings, and over here on the right hand side you can see that the rings are tucked just slightly behind the planet, and here they're in front of the planet. So it's not a total loss. This is better than you'll get in most cheap backyard telescopes. Still a little bit disappointing for tonight, but I've seen worse. So what we're going to do is I'm going to see if we can, I'm going to leave you guys with Saturn here, and I'm going to head back over to the other telescope and see what we can do to get Saturn in the view over there. It's 9:30. I don't think we're going to be able to hunt down some of the other outer solar system targets that we were hoping for. I was hoping to catch Neptune and Uranus and asteroids and comets, and some technical difficulties just haven't been able to get the telescopes to perform at their top here tonight. And as you've heard me lament a couple of times, the seeing conditions aren't necessarily ideal. So you guys enjoy Saturn for a second, and let me shift back over to the other telescope. All right, so we have Saturn ready in the other telescope, but before we go there, let's see what we can do as far as poking around and finding some moons of Saturn here on the big telescope. To do that, we're going to go ahead and Saturn centered in the screen, and then we're going to go ahead and, whoops, just like we did with Mars when we attempted to see its moons, way up, we're going to overexpose the planet itself, but we're going to hopefully pick up the moons in the process. And this motor is struggling a bit to keep track. All right, there we go. All right, let us see where the moons are. Oh wow. Yeah, okay, the dew must have built up to a large enough degree that we're not even getting the moons. Oh wait, there we go. Faint out there. That is going to be Titan, which is Saturn's largest moon. We'll go ahead and try and get this centered a little bit. The Cassini mission was NASA's main mission to Saturn, and it was active for years and years and years. It was spectacular in just so many ways. It had a passenger with it, and the Cassini probe was carrying the Huygens, Huygens, the Huygens probe, or lander, and Huygens was basically sent down to land on the surface of Titan. Titan, astronomers have been really curious about for decades because we can't see its surface. It actually has a thick atmosphere. It's the only moon anywhere in the solar system that has a thick atmosphere. So that was very intriguing. The fact that we can't see its surface, and there were some trace elements or trace chemicals in the atmosphere that were very, very intriguing to astronomers. Like, wait a second, we're seeing some carbon-based chemicals in here. Could this be a place where life could be sustained in some shape, manner, or form? And so the Huygens probe was sent to land and take as much measurement, gather as much data as it possibly could. Turned out the planet is, or the moon, I'm sorry, is very, very cold. There is liquid methane, lakes, and sometimes they say seas or oceans of liquid methane on the surface of the moon. And just like we have a water cycle here on Earth, they have a methane cycle up there on Titan. Spectacular images that the probe collected as it descended to the surface. It didn't last very long because basically the harsh atmosphere and the cold temperatures drained the life out of the poor sucker real fast. So it made it, I think it lasted a couple of hours before succumbing to the elements. All right, let me go check the view in the other telescope, and we're going to swap the camera back over there to return the view to Saturn through a telescope that is not covered in dew. All right, we're looking good. Let me go ahead and we're going to put the cover back on the Celestron. we're going to steal the camera and head back over to the Explorer Scientific. Whoa, you can see we had the settings turned way up on the camera, and so I accidentally pointed it just a little bit towards the screen, and boom. Minutes here on Saturn, because the official moment of opposition for Mars is in 11 minutes, and we are not going to miss that. All right, Saturn, we're turning down the gain. Let's turn down the exposure. Ooh, not too shabby. All right, there's a lot going on here, ladies and gentlemen. So let me keep playing with the focus, but you can see, again, you can see the disk of the planet. You can see the rings. Here we're tucking behind the planet. Here we're tucking in front of it. You can see the gap in between. If you look very closely, you'll see a tiny line in the rings out here and out here. That is the Cassini gap. Let's try and bring that, keep this guy centered. As you've seen, it's very difficult to re-find a planet when you're looking at it through a, well, you have the camera in the telescope and you're looking at it on the screen, and you've got to re-find the object. Can be quite tasking. So we can see the Cassini gap. And if you look carefully, I'm trying to get us centered here again, but you can actually see a little bit of color banding on the surface of the planet itself. That's pretty good. All right, we're gonna go ahead and we're gonna get some data here. Let's do a quick capture. What's our frame rate? 25 frames per second. That's not all that great. Kind of makes sense though, because we're streaming at the same time as trying to power a camera. All right. We are looking at Saturn at the moment, and let's do a quick capture, just getting 500 frames. And this is a black and white image again. We're not going through any filters yet, but we will do that here in a moment. Got to get the planet centered again. We're just going to take a couple more seconds, and then we are headed back to Mars. But while we have Saturn and the conditions are good, before it goes behind the tree, which will happen any moment, okay, let's go through the red filter. We're going to go, again, RGB, red, green, blue. And see how when we added the red filter there, yes, it did cut down the brightness, but that can be fixed in image processing. But see the Cassini gap, that faint line in the rings, is still very visible here. Okay, so let's go green. Last one is blue. And then the instant that's done, I'm pulling the camera out and we are headed back over to Mars because we are only 6 or 7 minutes from the moment, the official moment of opposition. And even my glasses are getting completely fogged up with dew here. Okay. There we go, we're good. All right, in order to do this fast, ladies and gents, I'm gonna have to leave you for a second. All right. All right, ladies and gents, I'll get this going as quick as I can for you. Sorry for the delays. I have a new finder scope that just arrived in the mail and I haven't been able to install it or align it yet. And the result is that finding planets is a real pain in the rear. Okay, whoa, Nikes, that was almost a fall. As the telescope spins out of control, we had Mars. All right, there we go. Okay, we have Mars. And we have my tracking motor. Just barely making it. All right. Let's change our settings. Let's get our focus. Seeing has improved a little bit from earlier, not a whole lot. But hey, I'll take any little bit we can get. And we are officially at opposition, ladies and gentlemen. I think that was about 45 seconds ago-ish. Now, we've got a good view of Mars here tonight. Tonight is the official night of opposition. We're now a minute and a half or so past it. But Mars is still going to be good for a period of time. The planets move apart gradually, and so we're still going to have a number of good nights, probably a week or more, where... Did we lose the live stream? Oh, you're kidding me. We lost the live stream? I'm going to keep... Oh, it says we're still going. All right, I'm going to keep going. I don't know what the computer's trying to tell us here. Okay. It takes time for the planets to move apart. Tonight is the best of the best of the best in terms of viewing conditions, well, in terms of the positions of the planets. And actually some people will debate that. Because the orbits are elliptical, the ellipses don't always line up. Technically, Earth and Mars were at their very, very closest to each other last week. I believe it was exactly 7 days ago. However, the opposition is very much like the full moon. It is when Mars is exactly on the opposite side of the Earth from the sun. So it's the full moon version. This is the night when Mars is truly, truly 100% lit up all across the disk. Even if technically last week Mars may have been ever so slightly larger in the sky, it's not going to have been so by a very significant amount. Actually, I'll check that here in a moment. I don't want to give you guys bad info. Let's get Mars back. Alright, so Mars tonight its apparent size is 22.3 arc seconds. If we go back 1 week in time, according to Sky Safari, Mars was 22.6 arc seconds. So enough that you will certainly not notice it if you're looking at it in the nighttime sky. 0.3 arc seconds is a very, very small angle. However, in a telescope, it could be noticed. Not significantly, but it could be there. Okay, so let's try and get Mars nice and focused again. Ooh. It's a very narrow band of focus, which again just goes to the seeing conditions being a bit rough here tonight. Although I am thankful that they have stabilized over the course of the evening. Well, ladies and gentlemen, it is 10 o'clock. And this officially concludes our show. Thank you for joining me. We were able to see a couple of things, although certainly not as many objects as I'd originally hoped to. Again, just some technical difficulties. I couldn't keep up with them. And so we were able to see Jupiter and Saturn and Mars. We were not able to get the rest of the outer solar system, but we will try those another time when everything is working a little bit better, and hopefully when seeing conditions have improved a little bit over what we've been going through here tonight. Just to give you a quick idea of the process here, as I go ahead and I'm going to say goodnight by going back to the beginning. All right. So thank you, ladies and gentlemen, for joining me here on the live stream for the opposition of Mars. It was a lot of work to get all of this stuff put together, but a lot of fun in the doing. Everything is covered with dew now, so I'm going to begin putting things away here. But thank you again for joining me. I'll be doing some more live streams later this year. I'm hoping to perhaps partner with someone in South America to do a live stream of the total solar eclipse on Monday, December 14th, my niece's birthday. No one is going to really be able to travel to South America to see this eclipse, and so we're going to see if we can find a way to bring it to you here on the YouTube live stream. I'll also be doing one about a week or so after that. It's been a great season for planetary viewing, and it's not over. Jupiter and Saturn are going to have a grand conjunction occurring in late December, I believe, on the winter solstice. A grand conjunction is when Jupiter and Saturn are very, very close to each other in the night sky. I believe that the numbers come out to, they will be closer to each other than the diameter of the moon. They will easily be visible in the same eyepiece view through a telescope or camera. And so we're going to take a look at those two planets as they reach grand conjunction, which only happens every 20 years, but it does happen like clockwork. So thank you for being here. Hope to see you again. And why isn't this working? There we go.